This lesson looks at the next method of factoring that we're going to be taking a look at, which is using the distributive property. Factoring using the distributive property. Remember, the distributive property takes what's outside of the parentheses and multiplies it by both things that are inside the parentheses. So if we're going to factor using the distributive property, we're going to pull out the common factor. So if we look at our terms, 2x squared plus 4x plus 8, if we look at all three of those terms, the biggest common factor that we see is a 2. So I'm going to pull out a 2. If I take a 2 out of 2x squared, I'm left with x squared. If I take a 2 out of 4x, I'm left with 2x. And if I take a 2 out of 8, I'm left with 4. So what do we have left? What we have left is x squared plus 2x plus 4. And you have to check, is that factorable, to see if you're finished. So if I was just looking at this particular part of it, because I know that 2 is already a factor, I'd be looking for two numbers that multiply together to make x, right, which would be x squared anyway. And then I'm looking for two numbers that multiply together to give me 4. So that's 1 times 4, or 2 times 2, and they have to add together to give me 2. There is nothing there that adds together to make 2, so our final answer would be 2 times x squared plus 2x plus 4, because that polynomial in the middle could not be factored. Then let's look at a couple more examples. So if I have 2x squared minus 8, if I pull out a common factor, my common factor would be 2. So I would have 2 out of 2x squared would be x squared, and 2 out of 8 would be minus 4. Then you have to look at the remainder. So x squared minus 4, can that be factored? That should stick out to you, as that's a difference of squares. So I still have my 2 as a factor, but then if I'm factoring the difference of squares, remember it's the square root of the first term, which is x, plus and minus, so 1's plus the square root of the second term, so square root of 4 is 2, and then I have x minus 2 as well. So that would be my final way of factoring. Let's take a look at this one. 4x cubed plus 20x squared plus 24x. I need to pull out a common factor. So my common factor that I could pull out would be 4, but this time it would also have an x with it, because each term has an x that I could pull out. So if I take 4x out of 4x cubed, I would have x squared. If I take 4x out of 20x squared, I would have 5x. And if I take 4x out of 24x, I would have 6. So my extra, or my remaining, is x squared plus 5x plus 6. So for that particular polynomial, if I was going to factor it, I'd be looking for factors of 6. So that's 1 times 6, or 2 times 3. And I want them to add to make 5. These two add to make 5. So I would have 4x times x plus 2 and x plus 3. And again, we know it's plus because those tell me they're the same, and then that one tells me that they're both plus. One more example. So if we look at this one, 45x to the fourth minus 20x squared. I want to pull out a common factor. The common factor I can take out would be 5x squared. So then I'm left with 5x squared out of 45x would be 9x squared, because it's the fourth power. And then minus, if I take 5x squared out of 20x squared, would give me 4. So we have to look at the remainder. 9x squared minus 4. That is a little harder to recognize, but that is also a difference of squares. So I would still have my one factor be 5x squared, but if I was going to take this and make it, I would have my one of them be plus and one of them be minus, otherwise it'd be exactly the same. And remember, to figure out what the two parts of the factors are, we'd have to take the square root of both terms. So square root of 9x squared is 3x, because the square root of 9 is 3, and the square root of x squared is x. So I would have 3x plus the square root of the second term, so square root of 4 is 2, so it's 3x plus 2, and then it would be 3x minus 2, because remember, a difference of squares, the only difference is that the numbers and the variables are the same. The only difference is that they have one plus and one minus. The last thing I want to take a look at is now if we're looking at factoring a polynomial like this one already has 4 terms. So you kind of want to start by looking at it kind of like it was part of the grouping method. With the grouping method, we created it to have 4 terms, but the first thing we did was we grouped the first 2 terms together with the second 2 terms. And I want to now look at each one and pull out my common factors. So I have x cubed minus 2x squared. So the biggest common factor that I could take out would be x squared. So if I take x squared out of x cubed, I'm left with x. And if I take x squared out of minus 2x, I'm left with minus 2. I want the other one to be x minus 2. So my factor that I'm going to take out would be negative 9. So I'd be left with x minus 2 on the inside. So remember, we put together what's extra. So that would be x squared minus 9. And then what is the same, or what's in common, is x minus 2. I have to then look at, can these be factored further? So if we look at the first one, x squared minus 9, that we should realize is a difference of squares again. So it's x plus 3 and x minus 3, because it's the square root of the first term, which gives me x, plus and minus the square root of the second term, which the square root of 9 is 3. And then I have to look at the last term in our one that we're simplifying, and that's x minus 2. There's nothing in common with x minus 2, nor can it be factored further, so I still have x minus 2. So this one has 3 binomials in its final product when it's factored.